Hello students, myself Dr. Jyoti C.K., Assistant Professor, Department of Physics. Title of the paper, Optical Instruments, Laser and Electrodynamics. In the previous class, we learnt about the spherical aberration. So today class, we will be learning about the chromatic aberration. So let us consider now a convex lens. So before starting this chromatic aberration, I want to make it clear that the difference between the spherical and the chromatic aberration is that in a spherical aberration, we have made use of the monochromatic light, that is a single wavelength. Whereas in a chromatic aberration, we are making use of the white light. As we know, the white light means what here? The white light is going to consist of the 7 colors will be there. So now these different colors, the white light is having the different colors which are having the different velocities. Where? In a refracting medium. So every refracting medium having the different refractive index. Okay student? Every refracting medium is having the different refractive index for each colors or in a wavelength. So now the refractive index for the violet color is a maximum, whereas the refractive index for the red color will be the minimum. Okay. Now the focal length is going to depends upon the refractive index, and this will be the different for the different colors. So now let us consider here, now white light is an incidented. If the parallel beam of white light is incidented on the convex lens, so what happens here? It will undergoes a refraction. So after refraction, the red rays are meeting at the point FR, there is a capital FR, on a principal axis, whereas the violet color is meeting at the point FV. So this point FR is far away from the lens, whereas an FV is nearer to the lens here. And this small FV is nothing but this is the focal length for the violet color, and this one FR is a focal length for the red color. Okay. In between the FV and an FR, we can see that the other colors are going to meet here. So one color, that is a dashed line, is represented by the yellow color. So as I written here, the rays of the intermediate colors meet in between the FV and an FR here. Okay student? Suppose now the screen is placed at the distance FV. So what happens here now? If the screen is placed at the distance FV, the center of the image will be the violet, while the outer surface is going to become a red color. Vice versa is possible. If the screen is placed at the FR, what happens here? The center image will be the red color, outer surface will be the violet color. Because of this image which is formed between the FV and an FR will be the blurred here. This is going to become a blurred. This blurred image, what we call it as an aberration. That aberration itself is known as a chromatic aberration. Okay student? So I will tell you now in the form of a definition, that is a defects in the images formed by the lenses due to the variation of the refractive index with the wavelength is known as a chromatic aberration. So now chromatic aberration is of the two types. As we learnt in the previous class, spherical aberration is of the two types. In the same way, chromatic aberration is also two types. What are those? The first one is a longitudinal. Another name for the longitudinal is an axial chromatic aberration. So this is a first chromatic aberration. Whereas a second one is a lateral chromatic aberration. So in the same way, spherical aberration is also, we got the two types. In the same way, chromatic aberration is also the two types are there. That is a longitudinal and another name for the longitudinal is an axial chromatic aberration. The second one is a lateral chromatic aberration. Now we will try to know one by one. What do you mean by this? First, longitudinal chromatic aberration. So I have written here the formation of the images of the different colors at the different positions along the axis. The images which has been formed by the different colors at the different position on this axis, that we call it as a longitudinal. So represented here in this arrow mark. From this point to this point, what you will get the image due to the different colors, that we call it as a longitudinal chromatic aberration. So now let us consider a white point object is placed on the axis of the lenses. So what happens here now? Now the that is the violet and the red images on the axis are represented by the IV and an IR here. Okay. Now the distance between this IV and an IR, that we measure it as a longitudinal chromatic aberration. Suppose now in terms of the focal length, how we will write the longitudinal chromatic aberration, that is an FR minus FV. FR minus FV we will write in terms of the focal length. In terms of the focal length. Now when this white light is object is placed on the axis of the lens, the violet and the red images on the axis are represented by this IV and an IR. Then the distance between the IV and an IR, that we call it as a longitudinal chromatic aberration. So therefore the longitudinal chromatic aberration is given by the difference between this IV and an IR. So this represents a longitudinal chromatic aberration. So now if the object, now this object is at the infinite. So what happens here? If the object is at the infinite, the longitudinal chromatic aberration will be equal to the difference in the focal lengths of the red and the violet colors. Okay student? So now the longitudinal chromatic aberration is said to be the positive. We are going to set to be the positive. When it will be the positive? Because we have measured it from IV and an IR along the direction of the incident light here. So this one is an incident light. This is moving along the direction of the incident light here. So the measurement which we made it from IV and make it as a positive here. So this, thus the chromatic aberration will be the positive for the convex lens. And similarly the chromatic aberration, that is a longitudinal chromatic aberration, will become a negative for the concave lens here. So I have written here convex lens, longitudinal chromatic aberration will be the positive. For the concave lens, the longitudinal chromatic aberration is going to become the negative here. So convex as well as a concave. So this we learnt about the longitudinal chromatic aberration. Okay. Now we will move to the second one. What is that? Lateral or the transverse chromatic aberration. The another name for this lateral chromatic aberration is the transverse one. Okay student? Transverse chromatic aberration. So in this one, let us consider now convex lens is there and AB is the object. AB is the object and this object is placed in front of the convex lens. So now the lens forms the image of the white object. AB has an BV, AB, BR and an AR. So this one is for the violet color and this one is for the red color. So the images of the other colors is lying between these 2 points here. So from the figure, the images of the red color is greater compared to the image of the violet color. Means what is happening here? There is a variation in the size of the images and that size of the image is different for the different colors or the wavelength here. So the variation in the size of the images, that we call it as a lateral chromatic aberration. So now the difference between this BR AR minus BV AV, that we call it as a lateral chromatic aberration. So this one I have represented here with an arrow mark. So this is a lateral chromatic aberration. Okay student? So I have written here the variation in the size of the image is known as a lateral chromatic aberration and the difference between the BR AR minus BV AV, that measures the lateral chromatic aberration or the transverse chromatic aberration. So till now we learnt about the chromatic aberration, what are the types of the chromatic aberration. So next class we will move with the another topic. Okay student? Thank you.